Hey, you guys, this is Mrs. Allday, Algebra 2 General, Remote Online Learning, Day 3, Child's High School. So if you would get out these notes that are 6-7 notes, we're going to do half of 6-7 today and then the other half of 6-7 tomorrow. So if you're not using the notes, you need to be doing this in your spiral composition notebook. All right, so we're doing inverse relations and functions. So we're going to start off with what are relations and what are functions. So we'll start with a relation. A relation pairs elements of its domain. Domain are your x values or your input. So down here in this mapping diagram, that's your domain. All right, so it pairs the domain with the range. Okay, the range are your y values and your output. So that's the other part of the ordered pair, your x and your y. Okay, so a relation basically are ordered pairs. All right, a function. A function is a relation. It has ordered pairs in it. But a function has only one output for each input. So what that really means is your x values are not repeated. All right, so let's look at this one right here and let's see, is the relation at the right a function? Why or why not? All right, so don't write down what I'm fixing to write down, but go ahead and kind of say it out loud or listen to me. I'm just going to list off the ordered pairs. You don't have to list them off like I'm doing. Just listen. -3, 4, 5, 4, 1, 0, -2, 0. Now, do you see if any of the x values are repeated? No. All right, since no x values are repeated, then this is a function. So is the relation at the right a function? So we're going to write yes. All right. Well, why is it a function? All right, so we're going to put y. So you're writing this part now. All right, yes, it's a function since the values in the domain are paired with exactly one value. All right, so this is a function, and that's why basically the x is not repeated. Another way that you've learned in the past to tell if it was a function is if you had graphed them and you saw that it passed the vertical line test. So let's go ahead and graph these right now. So we're going to graph these in red. All right, so -3, 4. Go ahead and graph these while I'm graphing them. 5, 4, 1, 0, and -2, 0. All right, so I'm going to call this f of x. That's going to be what we just graphed. So f of x is what I'm doing in red. All right, so that's the function. Anytime you need to pause it to catch up, just go ahead and pause the video. Do what works for you, okay? All right, now we're going to talk about an inverse relation. I'm going to do that in blue. With an inverse relation, all you do is you swap the domain and the range. That's pretty simple, right? All right, so we're going to do that down here. So write domain on the left, range on the right, and we're going to do a mapping diagram like we just did up there. So a box on the left, a box on the right. So I'm going to do 4, -3, and then the 4 will also be matching with the 5. So remember, we're just swapping them out. So my 0 that was a y value is now an x value. And the 0 is going to be matched with 1 and -2. All right, this is our inverse relation. And all we did was swap the domain and range. Now, let's go graph this one. So go ahead and graph this one. It might help doing it in a different color. All right, so 4, 5, 4, -3. I don't know why I did those in reverse order. 0, 1, and 0, -2. All right, pick up a different writing utensil, and we're going to draw a line that goes right in between them. Let me show you what I'm drawing. Y equals x. So 1 is the slope, and 0 is the y-intercept, but we don't really need to write it like that. This is y equals x. So I'm just drawing it, going down. Now, if you look at this line, you can see that the relation and the inverse relation are reflected. So there's one reflection, here's another reflection, here's another reflection, and then this red one and this blue one, that's another reflection. So that's pretty interesting too, that when you do the inverse, that all the points are reflected. Pretty cool. All right, so I'm a math nerd. All right, determine if the inverse is a function. We already did. Is it a function? Well, let's look at it. We determined whether the relation was a function, but we haven't done the inverse yet. So, is the x value repeated? Yes, it's repeated. It's used for -3, and then it's used again for 5, just like it's 0, 1, and it's 0, -2. So, yeah, the x value is being repeated, so no, the inverse is not a function. All right, look right below the graph where it says a relation and its inverse are reflections of each other over the line y equals x. All right, so that's the introduction to a relation and inverse relations. Let's go down here and let's see what we would do if they gave us, instead of a mapping diagram or a list of ordered pairs, they could have given it to us in a table. What if they gave it to us like this? Find the inverse of y equals 5x plus 2. Before we do that, let's graph that, okay? So remember, let me erase this so I can point to it. Remember, this is your slope, and this is your y-intercept. So you plot your y-intercept first, 2 on the y-axis. Your slope is 5, but you might want to put 5 over 1 to help you. You're going to rise 5, 2, 4, 5, and run 1 to the right. And then I go back to where I started at 2, and I fall 5, and I run 1 to the left. And then I do it again, 2, 4, 5, run 1 to the left. The reason why I do it so many times is I can't use a ruler right here, but you can. You can use a ruler or a straight edge, but I can't. So we're going to draw and connect those dots. I'm going to call this f of x. I'm always going to call the function that I'm working with first f of x. All right, so now we're going to do the inverse. So I'm going to do the inverse in another color, if you would do that as well. We'll go ahead and do the inverse in blue since we did that earlier. Now we're going to switch the places here. Okay, remember we're switching them. So this is going to be x equals 5y plus 2. All right, so now we want to solve for y. So I'm going to subtract 2 from both sides. X minus 2 equals 5y. All right, we're going to divide by 5. Go ahead and put a 1 here. That might help you in a minute. These ended up canceling, and these ended up canceling. So I'm going to write it in y equals form. So y equals 1/5 x minus 2/5. Now, doesn't that look like y equals mx plus b to you? Yep. There's a slope. There's a y-intercept. But we're going to graph this a different way. So let me erase this part so I have room. We're going to go back to the original problem. So I'm going to make this in green so you know I'm doing the original problem, this one. We're going to go see what some points were. So let's see, this first point right here was 0, 2. All right, this next point up here was 1, 7. All right, this point down here was -1, -3. This point down here was -2, -8. All right, so I'm going to erase all those little arrows. Now, we're going to go and we're going to do the inverse, and we're going to just flip those points. 0, 2 becomes 2, 0. 7, 1. -3, -1. -8, -2. Now go plot those. 2, 0. 7, 1. -3, -1. -8, -2. Connect your dots. And that was a whole lot easier graphing the inverse than it was. I'm going to circle it in red. So this is y equals mx plus b. Who wants to work with a fraction for a y-intercept? Not me. All right, so we found the inverse. The inverse is y equals 1/5 x minus 2/5. That was the inverse. Is the inverse a function? Yes, it's a function. There's lots of ways we could say it's a function. We could say, let's do this one. It passes the vertical line test because it passes the vertical line test. There's lots of different things we could say. We could say the domain is not repeated. We could say the input is not repeated. We could say the x values are not repeated. We could say for every x value, there's only one y value. There's lots of ways we could do it. So we've graphed the function and we graphed the inverse, and the inverse actually was a function as well. Now, when both of them are functions, it's called a one-to-one function. That means they're both functions, this one and that one. All right, we're going to flip the page over. For me, that is. Maybe not for you. You might have two separate pages. All right, we're going to find the inverse. Before we find the inverse, we're going to go ahead and graph this one. All right, so this is going to be my f of x. That's going to be my original problem. And before I go switching anything, I'm going to graph that problem. Now, if you look right there at the 2, you should think, that's a parabola. That's a quadratic equation. So when I get finished graphing this, if it doesn't look like a parabola, then I must have did something wrong. All right, so I'm going to do a table over here. And remember from whenever we worked on graphing parabolas that this right here, let me show you something real quick. Y equals x minus h squared plus k. All right, remember that was the form for a quadratic equation or parabola, and this k is on the outside, so that tells you to go up or down. Okay, so that -1 tells me I'm going to go down -1. Okay, but since there's nothing inside parentheses, because there aren't any parentheses, you're not going to go left or right. If we were going to go left or right, remember, inside the parentheses is a liar. That minus h tells you you're going to do the opposite of what you think you're going to do. So we'll wait till we have one like that before we do that. But that's just a refresher because we did that months ago and you might have forgot. All right, so I'm going to go down 1. All right, and so since I'm right there centered around the origin, I know I'm going to use 0, 1, and 2, and then I'm also going to plug in a -1 and -2. So since I know I'm right there at the origin, I'm going to go 2 to the right and 2 to the left. That's how I'm going to do it. Now I'm going to show my work over here in green, okay? So y equals 2 squared minus 1. That's 4 minus 1, which is 3. All right, let's go plot that one. 2, 3. All right, let's plug in 1. Y equals 1 squared minus 1. So that's 1 minus 1, which is 0. So let's go plot that one. 1, 0. Now, we learned that we can also reflect them, but I'm going to keep plugging in just so you feel comfortable doing both of them. Y equals -1 squared minus 1. Now, see how I put that -1 in parentheses? That's very important. When you have a negative and you're substituting it, it needs to go in parentheses. All right, so -1 squared is 1, and 1 minus 1 is 0. So that is -1, 0. See how that got reflected? Remember back whenever we had the axis of symmetry going down like this, and whatever points we got on one side, we just reflected to the other. So I know beyond a shadow of a doubt that I'm going to reflect this. If this is 2 this way, then it's going to be also 2 that way. So I guarantee you in a minute I'm fixing to plot that point. I'm going to go ahead and put it there and show you. All right, so I'm going to plug in the -2. Y equals -2 squared minus 1. -2 squared is 4, and 4 minus 1 is 3. And go check that out. -2, 3. Boom. Now, I did not put a point in right here because, look, it's already there. But let's put it 0, -1. All right, so go ahead and connect those dots. If you want to do a couple more, you can. But you need to have... Now, that's supposed to be a curve, you guys, but it's hard to do curves when I'm writing on the screen. All right. Is that a function? Yep, it's a function. Sorry, my phone's kind of blowing up over here for some reason. That is a function. So now let's do the inverse. We'll do it in purple. It's my favorite color. So remember, we're going to switch these out. Okay. So we're going to do x equals y squared minus 1. Okay, that's a little different. Doesn't look like our typical parabola, does it? So I'm going to add 1 to both sides. So that's going to be y squared equals x plus 1. Okay, I've still got to get y by itself. So the opposite of squaring something is doing the square root of something. All right, so I'm going to do the square root in a different color. The square root of this side and the square root of that side. So that's going to be y equals plus or minus the square root of x plus 1. Now remember, we have to do plus or minus because anything underneath a radical, like the square root of 25, that can be either a negative 5 or a positive 5. That's why we have to do the plus or minus, if you forgot that part. All right, so now we need to graph that one. But you know what? Instead of me having to put that in a table from that equation, I'm just going to do my table and go flip everything over here on the left. So 3, 2, 0, 1, negative 1, 0, 0, negative 1, and 3, negative 2. Yeah, that's going to be easy. All right, now let's go graph them. So 3, 2, 0, 1, negative 1, 0, 0, negative 1, and 3, negative 2. Now, this hasn't happened before. We haven't done a sideways parabola. This is the first. Interesting, right? So think about it. If it has a square root, and if plus or minus is in the front, that's what your problem is going to look like. It's going to look like a sideways parabola. Now, I'm going to change my color real quick. Is the inverse a function? No. Why not? Well, this is why not. It doesn't pass the vertical line test. It goes through 2 points at once. Every x has 2 different y's. So let's put that. Let's say every x has 2 different y values. All right. So you can even see that in the chart. Here, 3, 2, and 3, negative 2. 0, 1, and 0, negative 1. All right, so we graph the function and we graph the inverse. Now remember that I named the function f of x. If I wanted to name this new graph, I could call it the inverse of f. Right here, I'm going to do a little flower around it, a little cloud. That's really what I could call it if I wanted to. We'll go there later. All right, remember, pause it if you need to. I'm going to keep moving. Find the inverse of y equals negative x squared minus 3. All right, the first thing we're going to do is we're going to graph the original one. And you can look at it and see, hey, it's a parabola. All right, so I'm going to go put my x and y. I'm going to graph y equals negative x squared minus 3. Now that negative right there already tells me that when I get finished, my parabola should be upside down. It should be inverted. It should be reflected. And this negative 3 tells me I'm going to go down 3. So I'm going to go ahead and go to the origin, and I'm going to go down 3. All right, so if I go down 3, that point right there is 0, negative 3. I'm going to go ahead and put that in my chart. So I'm going to do a 1 and a 2, and I'm going to do a negative 1 and a negative 2. All right, so let's go ahead and plug those in. I'm going to do my work over here to the right again, where I did it earlier. So y equals negative parentheses 2 squared minus 3. 2 squared is 4, but you have to go put that negative out in front of it. So negative 4 and negative 3 make negative 7. Can you see that? All right, so let's write that. 2, negative 7. All right, y equals negative 1 squared minus 3. All right, 1 squared is 1, but you have to put the negative out in front of it. So that's negative 1 minus 3, which is negative 4. All right, so 1, negative 4. All right, now we're going to go ahead and reflect because we know how to reflect. So that's going to be negative 1, negative 4. I'm going to write that in my chart, my table. And then that was 2, negative 7. So it's going to be negative 2, negative 7. I'm going to write that in my table. And I'm going to go ahead and connect the dots. Like I said, it should have been an upside down parabola. And we had to go down 3 units. We had to shift it down 3 units. All right, the next thing we're going to do is we're going to find the inverse. All right, the first way we're going to find the inverse is we're just going to change the place of the x and the y. All right, so that's going to be x equals negative y squared minus 3. All right, let's add 3 to both sides because we want to isolate the y. So that's going to be x plus 3 equals negative y squared. So that means that these 3's canceled out. All right, so now I've got to get rid of that negative. So I can either multiply everything by a negative or divide everything by a negative. It's really easier if you just multiply everything by a negative 1. So that's negative 1 times x is negative x. Negative 1 times 3 is negative 3. And negative 1 times negative y squared is positive y squared. Yet we want our y, or our y squared, to be positive. All right, the opposite of squaring something is doing the square root of something. So I'm going to do the square root of the right side. It's going to give me y. I'm going to do the square root of the left side, but I'm going to have to put a plus or minus in front. So plus or minus the square root of negative x minus 3. Now that is our inverse function. I'm sorry, it's our inverse relation. We don't know if it's a function yet or not. Let's scroll up to the one before. I'm going to do this in neon so you know where I'm at. This problem right here was our inverse relation. When we graphed it, it was not an inverse function. All right, so what do you think is going to happen with this one? Should be the same thing because up here we had a plus or minus in front of the radical. Down here, same thing. All right, so we're going to graph this one. But instead of me having to plug in and make it hard, think smarter, not harder, we're going to go flip the chart. So for x, y, we're going to switch the x and y values. So it's going to be negative 7, 2, negative 4, 1, negative 3, 0, negative 4, negative 1, and negative 7, negative 2. All right, so let's go graph those. So negative 7, 2, negative 4, 1, negative 3, 0, negative 4, negative 1, negative 7, negative 2. And you see that it's a sideways parabola. Now that's supposed to be a curve, you guys. It's just hard for me to do a curve. All right. Is the inverse a function? No, absolutely not. Why not? Well, it doesn't pass the vertical line test. If I went and did this, I go through 2 points every time. So I'm going to say the same thing that I said before. Since every x has 2 different y's associated with it. I'm going to do with like that. Okay, so basically, think about it. Every x, negative 7, has 2 y's associated with it. Negative 4 has 2 y's associated with it. Okay? Or we could have said it didn't pass the vertical line test. But if you didn't have the picture, you couldn't really say that. You would have to say every x has 2 different y's. All right, so we graphed the function and we graphed the inverse. So if we were going to label these, for the red one, that was our original, that was our function. And then if we wanted to label the other one, we could put the inverse. Okay, but since we really don't have to write that, we are going to do this. We're going to label it by saying that it is right there. It is y equals plus or minus the square root of negative x minus 3. That's what that is. All right, this is going to be our last one for this lesson. find the inverse, tell me is the inverse a function, and then graph both the function and its inverse. So we're going to start like we did before. We're going to go ahead and graph this. Now, if you look at it, it's a parabola again. Okay, so you see that there's not a plus k over here. So that means it's not going to go up or down. On the inside, it's a -1. So that's the opposite of what you think. Remember, the parentheses are a liar. So you're not really going one to the left. You're really going one to the right. Okay, so if I'm at the origin and I'm going one to the right, that should be my first point. So let's start with that one. I'm going to plug it in to prove to you that it is the first point that we could graph. All right, so I'm going to show my work over here to the side. Y equals 1/2 of 1 minus 1 squared. 1 minus 1 is 0. 0 squared is 0, and 1/2 times 0 is 0. All right, see, there's that point, 1, 0. Now, this is where we have in the past drawn our axis of symmetry, because we know this is a parabola. It has x squared in it. And you're going to do at least 2 numbers to the right. So I'm going to do 2 and 3. And then we're going to do 2 numbers to the left, 0 and -1. That's how I determine what points I put into my table. Sorry, I was erasing. All right. So, oops, I'm doing red because this one's in red. So we're going to plug these in. So we have y equals 1/2. I'm going to start with the top of the table, 3. 3 minus 1 squared. All right, 3 minus 1 is 2. All right, 2 squared is 4. And half of 4 is 2. So that's 3, 2. All right, let's go graph that one. 3, 2. All right, let's do 2 now. Y equals 2 minus 1, which is 1. 1 squared is 1. And half of 1 is 1/2. I don't really like graphing fractions. So I'm going to erase that 2. I'm going to bring the 3 and the 2 down. Sorry, I had to turn my phone off. So I'm going to put the 3 and the 2 here. So I know that this 0 is going to end up with a half 2. So I'm going to put a -1 there, and we're going to go ahead and go fill it in first. All right, so if I put a -1 in, y equals 1/2 times -1 minus 1 squared. Sorry about that. -1 plus -1 is -2. -2 squared is 4, and half of 4 is 2. So that's the point that we normally would have reflected. So that's -1, 2. Oops, my bad. -1, 2. All right, so now we see that the 2 right here didn't work because we got a fraction and we don't like to graph fractions. So instead of me doing a 4, I'm going to put a 5 into my table. I'm going to skip it and do a 5. Okay, so let's see what happens. Put a 5 in. Y equals 1/2 times 5 minus 1 squared. 5 minus 1 is 4. 4 squared is 16. And half of 16 is 8. All right, that one worked. So 5, 8. So plot that one, 5, 8, and then reflect it. It goes 4 this way. So you're going to go 4 that way. All right, so let's go put that point. That's -3, 8. -3, 8. All right, so go ahead and connect your dots. And now we're going to, let me name it. This is my f of x. And we're going to go do our inverse. All right, so our inverse means we're going to switch these two. All right, so that's going to be x equals 1/2 times y minus 1 squared. All right, think outside the box. Okay, we got to get rid of that 1/2. How do you get rid of a fraction? You multiply by the reciprocal. So I'm going to use black so you know where I'm at. So I'm going to take both sides and multiply by the reciprocal, which is 2. All right, so that's going to be 2x equals, now these cancel, and I'm just left with y minus 1 squared. All right, the opposite of squaring is doing the square root. So we're going to do the square root of this side and get y minus 1. We're going to do the square root of this side plus or minus. We're going to do plus or minus the square root of 2x. All right, now we still have to get y by itself, so we're going to have to add 1 to both sides. So I'm going to add a 1 to the left and to the right. These cancel out. So I have y equals 1. I'm not going to put the plus sign in front. Plus or minus the square root of 2x. Now, let me show you how I don't want you to write this because it can be misleading. If you put y equals plus or minus the square root of 2x plus 1, it looks like that this plus 1 may be underneath the radical or it may not be underneath the radical. So, since we know it's not underneath the radical, put it on the left-hand side like I have it written so you know for sure. All right. So, that is our inverse. So now, do you think it's going to be a function? Nope, I don't think so either. Just because of that plus or minus and that radical. I think it's going to be a sideways parabola. So what we're going to do is instead of plugging in the equation like we had to do for the first one, I'm just going to go flip all my order pairs. So 8, 5, 2, 3, 0, 1, 2, negative 1, and 8, negative 3. All right, so let's go graph those. 8, 5, 2, 3, 0, 1, 2, negative 1, 8, negative 3. Connect your dots. And we were right. It was a sideways parabola. Is the inverse a function? No. I'm just going to say x values repeat. Although we know there's one that doesn't repeat. I'm going to circle it in neon. This is a 1 x value that doesn't repeat, but all the rest do. So we graphed it, and that's the inverse. All right, so now what we're going to do is I'm going to show you what your homework assignment is. I'm going to end up posting this for you, so you'll end up seeing this. But right here, if you look at 4.1, that's what we did today. Inverse relations and functions, graph and finding the equation. Your homework is page 410, 9 through 27 odds. Graphs must be on graph paper. So you need graph paper. If you don't have graph paper, you can go to my website, on the child's website. You can go to math under departments, go to Natalie Allday. I'm the first math teacher on the top. And I have graph paper there that you can just download if you need it. All right, so far, day 1, we did function operations, add, subtract, multiply, and divide. You should have watched 2 YouTube videos and did your homework. Day 2, you should have watched function operations, the composition, watched 2 videos and did your homework. But then you had a mandatory upload that you had to do. That's what's going to be graded. That 6-6 worksheet, when you upload it to Focus, you're doing only the multiple choice problems. Okay, and then I want you to add whatever the last multiple choice problem is. If it's like 5 for number 6, I want you to put yes or no that you watch the videos, however many there are. And then if the last problem was 5 and you just wrote, yes, I watched both videos for number 6. For number 7, I want you to put whether or not you did the homework. So this is kind of an honesty thing going on. But you've got to do the homework in order for you to do the mandatory upload, or you won't be able to do it. Now, when you do the mandatory uploads, make sure that you are saving it as a PDF or a Word document. Make sure your name is in pen. Make sure your name is on every page that you upload. You cannot just upload the worksheet. You've got to upload the pieces of paper that you do the work on. So make sure it's orderly and numbered and everything, because You don't know if I'm just going to count it as a completion grade or if I'm actually going to grade it. And if I don't see work, I can't count it as correct. All right, so today is 4-1. April Fools. Inverse relations and functions, graph and finding the equation. There's your homework assignment. As you see tomorrow, we're going to finish up 6-7. You're going to do your homework assignment. You're going to do the mandatory upload for 6-7. That's what's going into the focus. And then for 6-8 on Friday, we will do 6-8, and you will do the handout that is attached to Edmodo, as well as to the web page on Focus. And then you're going to do your mandatory upload. So basically, all these videos should have been watched, all the homework done, and the mandatory uploads done by Sunday at midnight. Because come Monday, April the 6th, we're starting a new section. All right, you guys, you're great. You are all that and a bag of chips. So thank you so much for being there and for going with the flow. And I'll see you tomorrow. Bye.